Hello and welcome to McLean 360. In this video, I want to solve a problem with you to illustrate the concept of a force which is in space. All right, so we are going to actually read the problem together and then solve it. All right, so a frame ABC is supported in part by cable DBE that passes through a frictionless ring at B. Now, knowing that the tension in the cable is 385 newtons, we should determine the component of the force exerted by the cable on the support at D. In fact, this is the same problem, but this time we will find the tension or the component of the force exerted by the cable on the support at E. So this is the summary of the problem. You know, there are cables here, and this cable is actually passing through a ring at a point B here. Now, this cable or these cables are preventing this from falling. And so there must be some tension in this cable. As a matter of fact, the tension in cable BD is the same as that of cable BE. And then it is given by 385 newtons. Now, this is the scalar of the component. This is the scalar of the magnitude. Let me put it that way. Now, if I want to convert this force into space, and then what I will do is that, so vector TBD is going to be the scalar BD multiplied by a unit vector along BD. In other words, we are saying that this, the tension here, BD, is joining between these 2 points. And so I will walk from B to D and describe a unit vector. Okay, so first of all, let's define a position vector BD. Position vector BD. So this is what I want to do. I want to walk from B to D. Now, this is how we do the walking. Every distance in this direction will be positive, and every distance along this direction will be positive. Finally, every distance in this direction will be positive. So let's move from B to D. So first of all, I will walk in this direction. And don't forget that moving in this direction will be against the conventional X. And so I will do minus 480I. And then I would actually move all the way here, and that is 600. And I will do that against the Z component. And so it's going to be minus 600K. And then finally, I'm actually going to climb up. So we are going to climb up, and then that distance is 510 in the positive Y component. Is that right? From here, I will finally settle down here. And doing that, it will be in the positive Z direction. Is that right? And that distance is actually 280. Is that right? So plus 280K. Now, if I am able to rearrange this, I'm going to get minus 480I and then plus 510J. So what is minus 600? So minus 600, and then I'll do plus 280. And what is that? Minus 320K. All right. So that is it. Now, what this means is that, in fact, this is actually in millimeters. What this means is that I've been able to express a position vector from B to D. And so if I want the vector BD, it's going to be the scalar, which I know, multiplied by a unit vector. And a unit vector is actually a vector. So vector BD divided by the magnitude of vector BD. All right. And so it's going to be 385. And then I'm going to multiply this by minus 480I plus 510J minus 320K. Then I will divide the whole of this by the square root of minus 480 squared plus 510 squared plus minus 320 squared. And that will give me the components of the force along the X, Y, and Z. And so what is this going to be? Let's pick our calculators and do this together. So pick your calculators. 385 is going to multiply minus 480. So minus 480, and then I'm going to divide this by, so minus 480 squared plus 510 squared, and then plus minus 320 squared. And what is that? Matter of fact, I'm going to get minus 240. So minus 240i. Then I'll do the same for the j component. This time around, I'll clean this part and make it 510. And that is going to be 255. So plus 255j. And finally, I'm going to clean the numerator and make it 320. That is for the z component. And what is that? So it's going to be what? Plus, oh sorry, minus 160. Okay. All right, so that is the force component in space. In fact, if I want to be sure that what I'm doing is correct, I can still find the magnitude using the magnitude formula, which is going to be minus 240 squared plus 255 squared plus minus 160 squared. And that gives me 385. Very good. It means that whatever I'm doing is good, is okay. Is that right? Okay. So now from here, what I would do is that so I'm done with the first part. So if I want to do TBE, I will do the same thing. Multiply TBE by a unit vector from B to E. Now, how do I do the unit vector? So first of all, let's do the position vector again. So RBE. Let's do the position vector analysis. So I'm going to move from B to E. Let's do that. So, okay, let me clean this. Now, this time around, I want to actually move from B to E. I want to move from B to E in that direction. Okay, so I would first of all move in this direction, which is 600, and then it is again the Z component. And so I'm going to do minus 600K. So minus 600K. From there, so I can climb up here. And that is going to be 400, along the positive y direction. So 400. So 400G. So plus 400G. And then I would actually come this distance here, which will be against the x. So it's going to be minus. But what is that distance? To be honest with you, the distance from here to here is 480. And then the small distance here is 210. Meaning that if I want this small distance, it's going to be 480 minus 210. And what is that? Let's pick our calculators. 480 minus 210. What is that? 270. So minus 270i. Okay. So that is the position vector. Now, if I want to, so let's rearrange this. It's going to be minus 270i plus 400j minus 600k. And this is actually in millimeters. Okay. Now, having gotten this, what we do is that we are going to actually multiply 385 by the unit vector. All right. I've written this formula already here. And that is going to be what? The vector divided by its magnitude. And the magnitude is minus 270 squared plus 400 squared plus minus 600 squared. And this is actually going to give me the component. So let's do it quickly. 385 and then minus 270. All right, divided by minus 270 squared plus 400 squared plus minus 600 squared. Is that right? Now from here, I'm just going to do this. Oh, so the first part is minus 135i. Then if I want the g component, I will just change the numerator and then I'll make it 400. Okay, so 400, and that's going to give me plus 200 j. And finally, I'm going to do minus 600. Okay, so if I do minus 600, it's going to be what? So minus, oh man. So I'll do 600 and then I'll divide it and then I'm going to get, so 300. So minus 300k. If I want to be sure that what I'm doing here is correct, and then I will actually find the magnitude. So minus 135 squared and then plus 200 squared and then plus minus 300, squared. Oh, 385. It means whatever I'm doing is correct. This is actually in newtons, and this is also in newtons. So that is the problem being solved. I hope you get a concept. Thank you very much for watching.